feeling tonight?
Good.
Fantastic. All right, so how many of us are familiar with or has developed anything with agentic systems or multi-agent architectures? A few of us, but how many of us use ChatGPT? I am surprised to see some of us don't. Well, so this talk is about building a conversation system that is more than just an LLM. So with an LLM, you might imagine like you might want to deploy that for some business use case. And oftentimes you have an intent, but what do you want the LLM to really do? And what kind of concerns or topics do you want the LLM to really discuss? And I was thinking of this vertical when I came across this use case when I didn't find LLMs to be very good at collecting information. If I want some information from a certain person, I can't really depend on an LLM oftentimes to get it to explore certain topics in depth until and unless certain criteria are met before it gives up and moves on to the next topic. That's what kind of led me to develop something I am currently developing, and it's called Langverse, which kind of uses multi-agent systems to keep track of different topics, so on and so forth. So let's start from the top, right? So what does the language model interaction look like, right? So you have just the language model and then you have the user. You're talking to the user. You're using the LLM to talk to the user, right? It's extremely fast. So there's a scale that you can see towards the bottom. It goes from fast to interpretable or controllable. So the more controllability or interpretability you want out of the system, the less fast it will get because there'll be more checks and balances, right? You want to do more validations, you want to do more evals, you want to do more guard training, all of that stuff. So what are the pros of this system, right? You can observe the chain of thought because most LLMs do pre-generation, like pre-output generation as well, which is like chain of thought reasoning. You can observe that. What you can't do is you can't control the thought process, what things it should be thinking about. You can't really control execution, what you're trying to execute, what tasks. And you don't also have validation of the executions, like is the execution valid in a given context, right? So there are some issues with this kind of a system. And when I say static context, I do mean with retrieval. So imagine like a RAG system that you're getting information from. For a particular text, it will always get you the same results because it's based on design similarity, right? So it is still static, it's not dynamic. Now what might be a second step beyond this, right? You might want to do something with a guardrail. You might want to have output guardrails, which is the most obvious one. Some people also advocate for input guardrails, which is when you're looking at what the user sent and you're trying to validate some things that it's not inappropriate to send to the LLM. That kind of input validation is useful when you're trying to do like maybe detecting malicious intent. Is somebody doing some kind of prompt injection, that kind of stuff, right? To mitigate certain risks. But you might want to use these kind of guardrails. So, but the problem is that it adds latency. So as you will see through most of this talk, one of the major concerns with agentic system development is that it keeps adding latency. The more agents you add, the more LLM calls you have to make. And for every LLM call, it's several seconds long. How much latency can you absorb in a production grade system, right? The good part about having some kind of guardrail is that the guardrail telemetry can inform your prompting strategy. So for instance, if you're seeing for certain use cases, the guardrail is constantly flagging the responses of the LLM. You might want to look at what are these scenarios, and you might want to have certain prompting strategies to mitigate those scenarios or have a better user experience perhaps, right? But this is less fast, like I said. It's somewhat more interpretable than just an LLM, right? Because you have the guardrail telemetry, you have some more inputs, you have some more controls, right? What can we do more than this, right? This is still not agentic, right? It still can't take actions, it's still just an LLM. Now, then you have a basic tree agent, right? So what do I mean by a free agent? A free agent is an agent that can do whatever it wants. It's not controlled. It is not constrained to a certain framework or a certain workflow. It has some tools available to itself, and it has an LLM. You can think of the LLM as its brain and the tools as its hands or instruments that it can operate, right? And it still would have guardrails, because after using all these tools, the response you're sending to the user, you still want to have guardrails on it. But it's less fast. As you see, like, by adding more and more things and going into like a React agent, how many of us know about React agents? So React stands for reasoning and acting. So it's an agentic mechanism where the agent uses an LLM to reason about a certain action, and then it takes the action, right? So I would say most agentic platforms rely on a reactionary mechanism. That it's reasoning about something, it's acting, it's reflecting on that action, or so far what has taken place. It's doing some more reasoning, acting, so on and so forth. There are several frameworks like this called Society of Minds, so on and so forth. But now you have a basic free agent. So now you have dynamic context building. Now, if you have a tool that can go out to the internet and search the internet and get you responses about what's happening on Twitter, or what's happening on maybe your company's Jira board, or what's happening somewhere else, you have access to dynamic context. You did not have access to dynamic context before in regular LLM use cases. You still don't have control over the thought process, you still don't have control over execution, you still don't have validation on that execution, right? It's very like control free, which is why I termed it free agent. It can do whatever it wants. It's still less fast because it has to go through the agentic loop. And now, on the other end of the spectrum, when you want a fully interpretable and controllable system, you might have what I call a control agent, right? So what is a control agent? A control agent is a workflow-based agent. So you're defining the workflow that the agent is going to take, and it's going to have several validations at each step of the workflow to understand has the workflow targets been met. If not, it's going to try some more. It's going to maybe ask the user for more inputs, right? That is that paradigm. And as you can see, it's still the same LLM as the brain and tools as the hands, but now you have a structured workflow and loops that go back and forth. Now you have control over thought, what things to think about. You can have structured outputs using any APIs, right? You can have validations that has this criteria been met, so on and so forth. And you can go back, mark that topic is not complete, and go back to the previous step and explore that some more, right? The problem, of course, of this kind of framework is that it's very high latency. Imagine you have 3 or 4 or 6 different user interactions, right? And validations at each step. It can become extremely high latency. Imagine for a single output, you might have up to 8 seconds or 7 seconds for a large output generation, right? Imagine a workflow that involves 6 or 7 different user, like LLM generations, validations, user interactions, so on and so forth. It can go up to 50 seconds, 1 minute, more than a minute, right? So this kind of a system, while very effective and simple, it can be very high latency. So the core point that I'm trying to make is that agentic systems can get very high latency. What are some ways we can potentially mitigate that, right? Because we need that. For my case, I was building a conversation system. Which user, in your experience, waits for 1.5 minutes before they get a response from an AI agent? They would rather go talk to a human instead, right? So, one way is to asynchronize as much of the workflow as you can. So you might have several agents, and you might want to think about how can you parallelize? What are the dependencies? Which agents depend on which other agents' outputs, right? If a tool call has been made and it's not getting the response back, do you want to retry? What is the frequency of retries that you want to do? All of these are parameterizable, right? You also need to evaluate the use of frameworks. Now, this is something that I did not use to think about too much, but this particular project, I started with using strands. How many of us have heard of strands as a framework, an agentic framework? Strands is one of few fully agentic frameworks. It came out of AWS. I was in the conference earlier this year, where they announced it. It's powerful. It's got context management that can be either file-based or Amazon S3-based. But using Strands, I got a latency which was about 3 times higher than what you would get with OpenAI's Responses API. Now that's interesting because in an application like Agentic Systems, where latency is already a concern, how much more latency are you willing to add to that, right? So think of the frameworks. Frameworks are great. They make things easier, and I think that's a great starting point. But think about the frameworks and how much you can use that in a production grade setting. Also, we need to evaluate the tolerance for wasted generation. So you'll see my project has an example of this, that how much of the generation are we willing to waste to make the latency concerns mitigated to a certain extent. So if 2 actions are dependent on the same input, and if one action kind of dictates whether the other action's output is valid or not, at that point do you even generate the second action? Because that's wasted tokens. If this validation doesn't pass, the second action doesn't have any merit to it, right? So are you willing to sacrifice tokens for having an easier or low latency user output? So that is something to think about. You can always parameterize the reasoning and the model. So in a classic LLM system, I have always advocated for the larger model, right? Use ChatGPT when you can, like OpenAI's GPT-5, whatever it is, because it's always going to be better in output. But when you're looking at an agentic system, when you're designing a workflow, right? The workflow often comes with structured outputs that you need the agent to do very specific things from very specific contexts. So do you need all that capacity to reason or think about, or, so you can use smaller models for agentic use cases. You can also tune the parameters of reasoning, which is like OpenAI has its own thing called like minimal, low, medium, high, things like that. You can parameterize, you can see how fast you can get without compromising on the specific task that you're trying to accomplish, right? You can also look at context quantity. Now this is huge because all models right now have huge context. But if you give the same model a lot of context, it's going to take more time to parse through all that context and to actually give you the right response. Latency will be higher. So you want to keep the context as low as possible for your structured use case. So now I want to talk to you about the project that I was talking about. It's called Langverse. So the idea is this, right? So the user is interacting with an application. The application has a front end, back end, all of that stuff. Now Langverse itself is a library, right? What does it do? It has 4 different agents in this case. It has an empath. It has an analyzer. Sorry, I don't know why the arrows are not showing. I believe there were arrows right here. Oh, the arrows are showing. So the empath is one of the agents. The empath agent, what it does is it tries to understand how the user is feeling. If the user is frustrated, or if the user wants to close the conversation for some reason, you don't want the agent to continue that conversation, right? You want the agent to kind of bring the conversation to a close, even if you have other stuff to discuss. Maybe the user can continue at a later time, right? That would lead to a better user experience. We have the analyzer. Now the analyzer agent analyzes the conversation and creates topics. Now what do I mean by a topic? Here's the paradigm. You have an objective. Imagine I'm deploying this system for understanding people's socioeconomic backgrounds. Now, what might a topic be, right? A topic might be where does the user live, for instance, or what does he do professionally, right? There's so many things that might come under that particular umbrella of objective, right? So you can set your own objective specifically, but you can also use the analyzer to generate these topics. A topic must have a context. That why does this topic even exist? If it's directly deriving from the objective, it might say, for this particular objective, this topic is valid. And there will be a criteria. A criteria is at which point do we consider the topic explored, right? At which point, how much of information when the user gives it to me will I mark this topic off, right? So that's a topic. So the analyzer is looking at the user's chats and picking out topics that the user has mentioned that might be interesting and putting it into a stack, which is the topic stack. In this version, it's a in-memory stack, like a Python object, right? Then you have the evaluator. So imagine the user is talking about a certain topic, has the user given us enough information to mark off this topic? Has the criteria for this topic been met, right? So the evaluator is really just checking it off. If it's checked off, then the conversation list will go to the next topic in the stack. If it's not checked off, the conversation list will probe some more. That, could you tell me this? This is the reasoning why it failed by the evaluator. Can you tell me about this, right? So it's a system that kind of probes more till that criteria is satisfied. And this is overall, the system works, right? If it's in memory, if it's exactly as you see, the system kind of works. Can anybody tell me from whatever I said so far, what might be a concern with this system?
I'm gonna guess latency.
Latency, there we go. You see the arrows, they're all sequential. It's like empath goes to analyzer, goes to evaluator, goes to conversationalist.
One question. Those in the architecture when building application for machine normally use microservices. So you have the latency from API calls to one another as well, right?
Right, 100%. But that is different latency though. Here we are talking about LLM latency.
No, I understand, but that adds as well.
Oh, 100%, 100%. But even like, one of the things that I kind of discovered is when you kind of develop production grade systems, it kind of becomes a software system in the end. We start off with the agentic framework, whatever we're doing, it's great. But then when you try to productionize it, you need persistence of memory. You need things that are crucial for software building, like software development. And you kind of have to incorporate those principles into the same thing. So latency is a big concern with this architecture, right? How can we change that? So this might be another way of doing it. So in this case, you have the application sending the message to 3 different agents: empath, analyzer, and evaluator at the same time. Now, we can turn off these agents as well. We can turn off empath, we can turn off analyzer if we want to. What's really important is the evaluator and the conversationalist. It's going to run out of topics if more topics are not added by the analyzer, but it can be deployed. What is interesting about this is that the empath and the evaluator runs in parallel. Now, the concern here is that if you're token sensitive, if you don't want to waste tokens, this doesn't work. Because empath might be like the user wants to end the conversation now. Your evaluation tokens just got wasted, right? You cannot have the best of both worlds. You kind of have to pick and choose between, do you want to waste some tokens, get lower latency, or do you want to do sequential, add latency, but not waste tokens? So in this case, empath and evaluator works in parallel. They have maybe 2 or 3 seconds, 4 seconds generation. And then that gets sent to the conversation list. The analyzer is, interestingly, the one that takes the most time because it needs a bit better model. It needs more reasoning to not include trivial questions to the stack, so on and so forth. So the analyzer asynchronously adds to the topic stack. In this case, also, it's not in memory. Topic stack gets sent out into a persistent database. Context goes out into a persistent database. Telemetry goes out into a persistent database. All of these are different types of databases, of course, Grafana, Mimir, all of that stuff, right? Different types of databases storing different types of things. Context, the place where you're storing the context, also needs to have vector stores. Because that is what you will leverage if you wanted to improve the system. You would want a system right after analyzer, right? Where that would look at a new question that's coming in from the analyzer, and it's going to evaluate whether the user has said something in the previous chat or the user's previous history with the system to understand if this question has already been answered or not. We don't want to ask the user the same questions again and again, right? So you have a vector store, you have some log store, metric store, that kind of stuff, and you have a topic stack, which can be stored in a table. It can be a lot of different things. So this would reduce your latency compared to the previous system by 50%. There, we were waiting for 4 different agents to complete their generations. Here, we're really waiting for 2 agents worth of generations, empath/evaluator and the conversationalist. So I want to end this slide deck at least with some thoughts. The thoughts are that agentic systems inherently, when you're developing them, they are agentic in behavior. The architecture is still pretty much the same as software development systems. So if you're developing a scaled out software, you think in the same way as you're developing an agentic system. It's a behavior you're really trying to emulate. And you can do the same thing using microservices. You can do the same thing using a monolith if you'd like. You can do all these software development principles while developing agentic systems. Agentic frameworks may add latency. So when you're talking about something like Strands, very powerful system. Something like Langverse, very powerful system. Like these frameworks are widely used today. But the problem is they may add latency. So when you're productionizing a system in a latency-constrained environment like agentic systems, you might want to rethink how much you want to use that. You might want to start off with a framework because they are very easy to use, easy to get started with. But maybe when you're productionizing, think again, is it still needed? Agentic systems will almost always add to the latency, but if you design it correctly, it can be mitigated to a certain extent, like I showed you. It can lead to a level of observability that you cannot have with plain LLMs or AI-driven systems. If you can, I would imagine like after you collect telemetry data for a long time, you might be able to fine-tune your own system with the agentic, or whatever you collect from the observability data from an agentic system to have a more responsive, inherently responsive LLM. But that is a longer term situation. With that, I wanted to show you a very brief demo of something of the Langverse system that I was building. But what happened is yesterday night, I was like, I showed 2 different architectures here, the V1 and V2. Yesterday night, I was like, it's great that V1 is working. Now we should totally do V2 without saving V1. So we have a broken V2 now, which you'll see very All right, let's see. Okay. So this is Langverse. So for objective, you might want to set explore the user's maybe professional background. Right? And then you set a max rounds per topic, which is 5, beyond which it will just fail that topic. It's going to process it, and it creates some topics, right? As you can see, the first topic is industry/sector. Industry, the context is industry. Context is crucial to interpret skills and experiences appropriately. Criteria is user identifies the industry or sector they work in. Example, fintech, healthcare, so on and so forth. Now, if I start the conversation saying hi, so you can also see the app state. So we have a topic stack which is 3 topics long. It has no explore topics and it has 0 current round. Like this is not the first round, so this is really the first round for this topic. So in this topic exploration, you can see that it's just saying the AI's message, right? To understand the background, it's important to get a sense of the industry you're part of. What sector do you work in? Imagine I say health check, right? And you can see the kind of the timestamps that it's taking. So the conversation agent took 2.3 seconds, eval agent took 4 seconds, empath agent took 2 seconds, and the analysis agent took 5.9 seconds. So the analyzer agent will keep on increasing time as the context keeps growing. So as you can see here, the analyzer agent took 14 seconds, for instance. So got it here in health tech. So in the topic exploration, you can see that it added certain topics. It has a bug over here, of course. It's saying the same thing twice. But essentially what it's done is it's added seniority level to the stack. And the first one that it pops from that stack going forward is the seniority level. It's a stack. So now it's going to explore seniority level, so on and so forth. So this is kind of the idea of having an agentic note-taking system, because agentic systems inherently offer us this capability to take notes on the fly and kind of act on those notes. So this was Langverse. Thank you for attending. Any questions?
So you mentioned that this system can add latency, and so you advocate for in production that they go directly to call the API. Is that what you're doing here?
Not quite. So I would say. Could you repeat?
Sure. My question was, I just wanted a clarification if in the production system that you have developed, you are directly making call to the API, or if you're using this framework.
You are making direct calls to the API 100%, but the way you are orchestrating it is the difference. So you're trying to asynchronize as much as possible in those API calls. It doesn't matter if it's an API call to OpenAI or if it's an API call to some server rack you're hosting with Llama 7, like Llama 3 in it, 7 billion, which will probably be fast, right? So it doesn't matter what API it is. It's just an LLM in the end. The way you're orchestrating it is the differentiating factor.
So I do have two quick questions. First question is, latency is the main issue today, but how much the hardware today that we have GPUs impact on the latency? Did we reach the limit and we need another set of GPUs to decrease the latency of this processing, or we still have room and is more architectural behavior?
So I think that totally depends on what you're trying to run. So imagine if you have a small enough language model, imagine like a 3 billion parameter model, you can probably run it on your computer. You don't need it like full-fledged GPU for that. It depends on how much model prowess you want, like how big of a model you want to run and what resources you have. So if you're saying that if you have a trillion parameter model, is GPU the bottleneck? It's always that game between how big the model is and how powerful the GPU is. It's a balance in the end.
One question that also popped in my mind is to try to reduce latency. I know that you have the stack topic, but as soon the user starts making the conversation, it's possible to make predictions of the topic and load it in cache. So instead, if you hit a topic that you predicted that user will touch, you reduce the latency while this cache is updating in background.
So not necessarily. So what the analyzer agent is doing, in the second V2 of the architecture, you saw the analyzer agent was completely standalone, right? It's asynchronous. So most of the time that the latency consideration comes with the conversational agent and the evaluation agent and the empath agent, right? These are the three ones that are like evaluating every single user response, right? So the analyzer, I wouldn't think too much about it because it's going to keep adding topics to that stack. Over time, that becomes irrelevant. Like even if it takes like a long time to add a new topic, it can do so because there's already a few topics left to explore.
Something I found difficult is like just evaluating these when you need to test like a kind of back and forth and like sending there like typing out like a new message every time because I can't use a preloaded thing because the agent has given me a new message because I changed something about it. What do you? I don't know. Maybe this is a common problem, but I'm curious what you do.
Could you repeat the core problem itself?
Like testing is hard when the situation keeps changing because it is a dynamic system that's not giving me a repeatable testing environment, basically. I don't know if that's
Right, 100%. And a lot of that is a real concern, like evaluating agents' performances and things like that. And we have Jayesh who will talk a little bit about benchmarking and eval and all of that stuff later. But I think eval is very valid concern, but I would suggest when you're starting off a project, don't think too much about evals. Like traditional software relies a lot on testing the framework itself. Like, is the structure going to work? And as long as the structure works, I think it's fair to put in guardrails and kind of evaluate, like take in as many logs as possible and do analysis on those logs and see how much of those guardrails are being hit and kind of analyze those context by context basis.
Thanks, it was good. I just had one question. When I started, you talk about Langverse, you mentioned a very big concern about context. That as the context length increases, model latency increases as well. What about Langverse? How it resolving the context problem? Because if I'm right, usually after 15 conversation, model tries to forget the whole data. Does Langverse solve that problem as well?
Well, the conversation system itself would keep on asking more and more questions and it will increase. But I think when you're looking at the evaluator, right, you have a single topic, it has a single criteria, and it's trying to solve for that criteria. It's going to look at the user's latest response, and it's going to look at, has this criteria been solved from this subset? So if you look to the right, you have topic-wise segmentation of the chat. So you're not looking at the whole context of the chat itself, you're looking at this topic's exploration. And within that exploration, it should be short enough to evaluate that particular criteria.
Okay, so if I'm right, we are not focusing on the old data itself, we are just focusing on the new latest data provided by users and focus just on
but the context part, like I mentioned in the last V2 version of that, when you have a vector store having all the context from before, then you're pretty much choosing how well you're going to chunk it, right? So it depends on, are you going to summarize texts? How are you going to really evaluate that? So there are ways to mitigate that context concern.
So if we are bringing summarizer, don't they bring the latency as well? Because now it would be like extra model which would do the summarization for us.
Yeah, but that can be asynchronous. That can be at ingest time. That doesn't have to be query time.
Just back end of that. Oh, makes sense.
Yeah.
Thanks.
So one of the questions that I have is, you were showing us your agent architecture, right? It was going from one agent to another. So the issues that I found with multi-agent architectures is if one agent makes a mistake and then passes that information along, it just becomes it just keeps adding on to the mistake and it gives like worse answers. So when you're building a system like this, how do you have guardrails to prevent that?
Right. So that's very valid if there is information propagation. So if you're taking the decision of one agent and propagating that same line of thought to the next agent by modifying the information in some way, then you can imagine it can be a divergent path, right? It diverges a little bit and then it diverges a little bit more. The thing is, in my particular architecture, it was more of different agents doing very specific things against not exactly. I would say the evaluation is happening on a preset benchmark, which is the topic. It has a certain criteria, it has a certain context. It kind of grounds it back to what it's trying to do. If the first agent, the empath agent, even if it was wrong, it would not have that much of a bearing on that. So it would know that the user might be feeling tired or whatever. It's still going to evaluate and it's still going to do some work in the background without going to read too much.
Any other questions? All right. Thank you so much.
Thank you.